today we're looking at your Unit 7 quiz review, getting ready for that quiz you have coming up over targets 1 through 7. So we're going to start off with targets 1 and 2, which are paired together. Target 1 is the graph of a square root function, and then target 2 is the information, so the domain range in zeros. So I want to start off by reminding you what the parent function will look like. So this is your square root function, which means we're going to have all perfect squares as your x values. So the smallest perfect squares is 0, then 1, then 4, then 9. And then the square roots of those numbers, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So that's the parent function we're going to base everything on today. So on number 1, there's a couple transformations. So under the square root, it says x minus 3, which actually means we're going to go to the right 3. So I'm going to add 3 to the x's. And the plus 4 at the end means we're going to do y plus 4. We don't switch the sign there. So from the parent function, I'm going to add 3 to each of the x values. So that would be a 3, 4, and then 4 plus 3 is 7, and then 12. And I'm going to add 4 to each of the y values from the parent function table. So 4, 5, 6, 7. And I'm going to go ahead and graph these points. So starting with 3, 4, 4, 5, 7, 6, and then the next point goes off. So I won't worry about that. And then our graph goes in one direction just to the right. So just keeping true to that trend. Our domain, so looking at the x value where your graph starts, it starts at the x value of 3. So our domain is going to be x is greater than or equal to 3. And the y value where it starts is 4, so y is greater than or equal to 4. And notice that that's the same x and y value from your chart up here, so you can always use that to kind of double check your work. The zeros would be x-intercepts, and we can see this graph does not cross and will not cross or touch the x-axis, so we can say none. All right, so going back to that red parent function in the middle of the smartboard, and then using new transformations here on the second example. So under the square root, it says x plus 1, which we know means it's going to go to the left one, so that's why I did x minus 1. And then keeping the sign the same for the y, so y minus 2 for that number out and back. I'm going to subtract 1 from each of the x values in the parent function table, so that becomes -1, 0, 3, and 8. And subtract 2 from each of the y values, so that would become -2, -1, 0, and 1. And I'm going to plot these points. So starting with -1, -2, 0, -1, 3, 0, and 8, 1. And creating that same pattern to the look of the graph. The domain, it starts at the x value of -1, so x is greater than or equal to -1. It starts at the y value of -2, so y is greater than or equal to -2. 3, 0 is going to be the point where it crosses the x-axis, so you can write x equals 3, or if you want to write the point 3, 0, that works as well. All right, moving on to target 3. So we're solving square root functions and checking for extraneous solutions. So as a reminder on these problems, we have to get the square root by itself and then square both sides to get rid of the square root. So I'm going to start by subtracting 5 since that's not under the square root. And then to get rid of the square root, I'm going to square both sides. And now it's just basic solving skills, so I'm subtracting 1 and dividing by -4. So x equals -3/4. If we plug it back in, remember you always have to check your work on these problems. Five plus 1 minus 4 times -3/4 equals 7. So that would be 5. And if I calculate that, that's the square root of 4 equals 7. 5 plus 2 is 7. So that all works out. Then on letter B, got to get that square root by itself. So I'm going to start by subtracting 4 from both sides. So then I have 18 equals 2 times the square root of x over 3. Then I've got to get rid of that 2, so I'm going to divide by 2. And then to get rid of the square root, I would square both sides. So 9 squared is 81. And then to get x by itself, I have to get rid of the divided by 3, so I'm going to multiply both sides by 3. And I get 243. Before I can finish this problem and say that's for certain the correct answer, I have to plug it back in. Always checking for the extraneous solutions. So I'm just plugging it back into that original problem. So 243 over 3, that's just 81. And the square root of 81 is 9. And we can see this is a true statement. 2 times 9 plus 4 is 22. All right, moving on to C. So when you have a square root equals the square root, it looks tricky, but it's actually pretty easy. Let's start by squaring both sides and lifting the square root off of both of those. So now to solve, I'm going to add x. So I have negative 2 equals 3x plus 28. And then I'm going to subtract 28 over. So I get negative 30 equals 3x. Divide by 3 and I get negative 10 equals x. So before I say that that's my final answer, I do want to check my work. So square root of negative 2 minus a negative 10, so that would be like plus 10, equals the square root of 2 times negative 10 plus 28. No parentheses needed there. So that would be the square root of 8 equals the square root of 8. There's no negatives under the square root, and that's a true statement, so that's good to go. Our last problem for target 3, we have our square root by itself, so we're going to square both sides. But the tricky thing about this one is you have to remember to square x minus 2. In other words, you have to do x minus 2 times x minus 2. It does lift off the square root off of the right-hand side. If I FOIL this, I get x squared minus 2x minus 2x plus 4. And combining the two x's, I get x squared minus 4x plus 4 equals x. This is a quadratic, so to solve it, you have to have it equal to 0. I'm going to scooch that x over. And then I'm going to use my factoring skills. So I'm going to try to find numbers that multiply to 4 and add to negative 5. I think negative 1 and 4 work for this. So our factors are x minus 1 and x minus 4, which means our possible solutions are 1 and 4. We do have to check those answers. So I'm going to start by checking x equals 1. So if I plug that into the original problem, 1 minus 2 equals the square root of 1. Negative 1 is not equal to the square root of 1. That is not a true statement. So x equals 1 is not a solution. And then if I plug in a 4, so now I'm checking the second answer, 4 minus 2 equals the square root of 4. 2 does equal the square root of 4. So that is a true statement. So our only solution there is x equals 4. Moving on to targets 4 and 5. So for targets 4 and 5, we have our cube root function. That's the graph. Is target 4, and then target 5 is going to be finding that information below the domain range in zeros. So I'm going to start with the parent function. And so for a cube root, the parent function is going to have all the x values of perfect cubes. And this can be negative numbers since it's a cube root. So -8 is our smallest perfect cube that will fit on our graph, then -1, and then 0 and the positives of those values. The cube root of -8 is -2, cube root of -1 is -1, and then we get those positive outputs here. So that's the parent function. Starting with A, I'm going to look at what our transformations are. So it looks like x is going to be going to the left 5, and y is going to be going down 2. Remember to always do the opposite for your x values. So I'm going to subtract 5 from each of the x values, so that's -13, -6, -5, -4, and 3. And then subtracting 2 from each of the y values, -4, -3, -2, -1, and 0. So I'm going to plot these points, or at least the ones that fit on the graph. So I'm going to start with -6, -3, then -5, -2, -4, -1, and 3, 0. So remember these graphs, they kind of look like a big S. It's a sideways cubic, so it should go forever in both directions, unlike that square root function from targets 1 and 2. So domain, how far to the left and right does it go? Forever. So we say all real numbers, however you want to say that. And for the range, it is also all real numbers. For the zeros, where does it cross or touch the x-axis? That would be at x equals 3. So same idea here on B, going back to that parent function I wrote on the left-hand side in black, just applying the new transformations. And remember that exponent of 1/3, that's the same as a cube root, so don't let that get you confused. So we're going to the right 2, so x plus 2 and y plus 3. So going back to the parent function, I'm going to add 2 to each of the x values, so that becomes -6, 1, 2, 3, and 10. And I'm going to add 3 to each of the y values, so that's 1, 2, 3, 4, 5. And I'm going to plot all these points. I think it all fits on the graph. -6, 1, 1, 2, 3, 4, oh, 2, 3, there we go, and 3, 4. I skipped one. And then 10, 5. So then the graph is going to just kind of squiggle across. It doesn't matter how we shift our graph, it's still going to go forever to the left, forever to the right, forever up, forever down. That's what's nice about these graphs. And then our last function here, it's going to the left 1, so x minus 1, and going down 1, so y minus 1. So subtracting 1 from each of the x's and the y's, starting with the x's, and now subtracting 1 from the y's. And then plotting these points. So -9, -3, -2, -2. Make sure that your tables, like the parent function table that you need for targets 4 and 5, and then also 1 and 2, all of that's on your reference sheet. You can't use your reference sheet on your quiz, but you can use it on your test, so you might as well go ahead and put it on there. And again, as I said on B, it doesn't matter how we shift our graph to the left and right, up or down. Our domain and range remain all real numbers. And then we can see that it's touching the x-axis, crossing the x-axis at the x value of 0. Our next target is target 6, so solving equations with rational exponents. So our goal here is to get whatever's being raised to the exponent by itself. So in this case, on letter A, we're going to get all of this by itself to start off with, which means I'm going to start by adding 4. And then I'm going to get rid of that 2. I'm going to divide by 2, so make sure you don't distribute it. Okay, so at this step, if we want to get rid of a rational exponent, we raise both sides to the reciprocal exponent. So the reciprocal of 1 over 2 would be 2 over 1, which is just 2. So do that to both sides. So then 5 squared, 5 to the second power is 25. Now we can get inside these parentheses, so x plus 2, we've gotten rid of the 1/2, those canceled. And now just basic solving, so subtract 2, 23 equals x. Over here on B, the only thing being raised to the exponent is the x, so we have to get rid of the 1. And then to get rid of the 1/2, you can either divide by 1/2 or multiply by the reciprocal. We talked about that last unit. So that would be x to the 1/3 equals 4. And now to get rid of the 1/3, we take both sides to the reciprocal exponent, which would be 3 over 1, or just 3. So that leaves us with just x on the left-hand side, and 4 to the 3rd power is 64. Make sure you don't do 12. That's 4 times 3. We're doing 4 times 4 times 4, 4 to the 3rd power. And then our last target that's going to be on our quiz is target 7, which is converting to and from radical and exponential form. So we're going to start off this top row by switching the radical form to exponent form. So if there's not a number as an exponent, you can assume that that's just a 1. So this would be x to the 1/6. So as a reminder, your exponent goes in the numerator. Your index, the number that goes with your radical, goes with the denominator. So same pattern here, nothing tricky, x to the 5/4. C has two things going on. So first of all, it is in the denominator, which means our exponent's going to be negative. And also, whenever there's not a number out in front, we assume it to be an index of 2. That's kind of a tricky thing that I will try to trick you on. So we would have x to the -5/2. Make sure you got both those things. So now we're just doing the opposite. So on D, I'm giving you the exponent form, and you're going to put it in radical form. So the first thing I notice on D is that there's a negative exponent, which means we have a 1/, situation. And then just doing the reverse of what we were doing before. The denominator goes with the radical, it's the index, and then the numerator is the exponent on x. So here we have the second root of x to the 5th power. And remember, you actually don't need to write this second root. You can just say the square root of x to the 5th power. Either one's totally fine. And then on f, another negative exponent, so 1 over the 7th root of x to the 1st power. And you actually don't even need to write that 1st power if you don't want to. Either one of those answers would be great. So make sure you're prepared for your quiz. Make sure you're working on your reference sheet. Even though you can't use your reference sheet on your quiz, still important to put this information on there while it's fresh.